Welcome everyone. This is the Spark on Kubernetes call on 23rd of January. As always, we're going to record this call and we're going to publish on YouTube, and we follow CNCF code of conduct. So as always, like we start this call with a quick introduction. Do we have any new people who are here on the call who just want to say hello? Maybe want to introduce yourself. Feel free to use chat or just say hi to the community. Hi, Yush. Do you want to say something? Introduce yourself. Yeah, I think we can hear you if you're talking. You're on mute.
Okay. Hi, everyone. Uh, Joined the Kubeflow community recently and looking forward to contributing to it. Thank you.
Yeah, thanks for joining this calls.
Welcome.
Anyone else before we get started? All right, then I guess let me maybe share my screen. We can quickly go over the agenda items. So I think just a reminder, we started this call from this year. So we're kind of like rebranding the Spark Operator call to this new Spark and Kubernetes community calls. So our goal, as Vara discussed last week ago, 2 weeks ago, we tried to bring folks who try to kind of migrate the data workloads to Kubernetes. Specifically, it could be, Spark, Flink, Trino. We focus on Spark heavily right now, but eventually we try to, give a space for folks to talk more about data on Kubernetes. And I think there are a lot of topics and interesting discussions we could have around how we can accelerate Spark with data fusion or Gluten or any other, engines to make sure, folks who start to do this migration have the most performant way to run those data processing and streaming workloads on Kubernetes. And again, like as we suggested last time, if you have any topic or if you want to demonstrate maybe how you use Spark internally, whether you use Spark Operator, whether you use Spark Connect or any other orchestration tools, we will be happy to give you space here to talk about your experience or maybe ask any questions. And if you want to propose any topics to the future agenda items, we have this meeting notes. So feel free to add your name here and we can contact you over Slack or email to talk about those updates. Um, Yes, I think today we have two topics to talk about. This first one is the MCP server that Manu will present around Spark History Server. And also I want to give a short overview what we do with the Spark Connect in the Kubeflow SDK. Um, so Manu, do you want me go first on this Kubeflow SDK topic and then jump to the MCP?
Yeah, that sounds good to me.
All right. In the meantime, if you want to add something else to the agenda, we have this doc. We have few, we have time today, I think, to talk about other things. So I think I'm just maybe want to remind everyone we try to work. We're working right now on the integration towards Kubeflow SDK. And for those who are not aware, like we try to give a Pythonic experience for data scientists and ML engineers to do large scale ML on Kubernetes using just Python. And today we already support other projects within from the Kubeflow ecosystem, which is Trainer and Kteep for Trainer for distributed training, Kteep for hyperparameter optimization, and also we integrated recently model registry for to storing your artifacts and catalog of models. I think they're also planning to support MCP servers for discovery, so it will be more kind of a hub for your ML artifacts. And our goal is to also support Spark Operator for large-scale data processing. And we started this proposal, I think, a couple of months ago to integrate Spark clients to Kubeflow SDK, so folks can do something like this. So we try to give them a single client, which kind of like a Python client, which allows them to connect to the existing Spark cluster, or allows them to submit the Spark jobs using just PySpark and Python. So this is very useful for folks who probably don't know what is Kubernetes, who don't know how to construct YAML files or build those Docker images, but they just know maybe PySpark. They know how to write transformations, and they want to have a quick way to scale or maybe deploy their Spark workloads in Kubernetes using Python without, even touching kube control or, like REST APIs or any other, Kubernetes resources. And I think we started with, we've been thinking about two different experiences. So the first one is to provide a sort of connect API, which allows users to connect to the existing clusters, or we will create the Spark clusters for users on behalf of the users. And then they were using this, we kind of like, we creating the Spark connection to those clusters so users can execute queries in real time. So behind the scenes, we're using the Spark Connect CRD. So this is the new CRD. I think Kichian is created in Spark Operator, which allows us to actually create the stateful connections. And, like experience looks pretty good. So it's like, you just run a simple API and then you can execute the queries on those clusters. And everything is hidden, behind the scenes. Users can construct how many executors they want to use. They want to, configure resources. They can also configure Spark configurations, like other Spark properties via this API. But we find this very useful for users to try out. I think I also want to say that so this is our first experience. We already have the working PR. So this is the PR that Shahar is working on. So right now we're trying to kind of like um, make it consistent between experiences. So between our multiple clients, how to make it easier for users to have same experience for training, whether we use PyTorch or using Spark for data processing, how we can give them, like as seamless experience as we can. And I think there are a couple of examples we also do have here, how, I think it's already working, but if you're interesting, I suggest you to explore some of those examples, how you can do some simple transformations. Yeah, so yeah, please take a look. I think the goal is for us to provide this Connect API initially, so users can get some initial value with these kind of stateful connections, and then we also want to work on some sort of job submission API where users can not only connect to the clusters but maybe create a batch Spark jobs. And I don't know if we have some examples here. Let me quickly see. Yeah, submit job. So I think like there are some, we kind of try to also provide abstractions on top of Spark application CRD. So if user wants to have like, like interactive sessions, they can use Spark Connect. But if users want to submit the batch jobs, they can use the submit job API to kind of create this Spark jobs, batch jobs without even touching, kube control or Kubernetes API, etc., just using the Python API. And just maybe just the last point I want to say that here we try to let me quickly go over. I think it's somewhere here. Function. Yeah, I don't know if you have example, but like basically the idea is to also allow users to submit Spark jobs from the function. Like let's say because Spark applications are really quite complex, you need to configure pod template, pod spec. So we try to give them similar experience we do with the PyTorch, where users define the function, they define all the PySpark transformations there, and then have a simple API to convert this function to the Spark job. And then, users can say how many executors I want to use, how many, like what kind of resources I want to use for those Spark jobs. So it's pretty, it's easy, but at the same time, it gives user like ability to integrate, where you use, pipelines, how you integrate with other, engines or other, orchestration tools you're using to submit those Spark jobs. So I think like this experience is pretty interesting to investigate. I think it's somewhere. So this is the example for me, right? So let's say you have a function where you define all of your Spark transformations, and then you have a simple API to convert those transformations to the Spark job. And that's it. Like, like one single line of command to convert this to the Spark application. And this is running on Kubernetes at scale, and you can easily, configure the resources here. So this is like the work stream we're doing. So any questions so far? Maybe discussions you want to have?
I
And
might
I
have
had a
missed.
Yeah.
Oh,
You're good.
sorry. Go ahead.
yeah, Manava,
Okay.
thanks. And I had a question, right? So behind the scenes, are you using the Kubeflow Go operator, or you are using the new Java operator that was released?
Yeah, so here we're using still this Go operator. So we're using the Spark application CRD and Spark Connect CRD, which is part of this Go operator. Yeah, because we try to, I know there are two operators exist, and they have like Spark job CRD. We do have Spark application CRD. Yeah, for now we're using the hour, like which we maintain the CRD. So
Okay, perfect. Thank you.
yeah, Manabu, you have a question?
Yeah, so did you say this uses the Spark Connect CRD to create the Spark Connect instance?
Yeah, that's right.
Okay.
So behind the scenes, we do create the Spark. So we do have. I think this needs to be a little bit refactored, but let me quickly show you. I think it's in utils. Yeah, we do create this object, like the Spark Connect CRD, which has a specific specification, like the required spec. And then we create we just bypassing as output is the Spark session, which allows us to use this, the PySpark Spark Connect to connect to this session. I think we have some examples in the client.
Looks
But
like
let's
you
say,
don't.
yeah,
Oh,
good.
yes. Just gonna say, so you don't look like it doesn't look like you have a rigid spec field. So it looks like it's just uh, just a dictionary. I I
Yeah.
glanced at it, but
You mean like how do we create the CRD, or what do you mean?
yeah, like in CRD, so you have look like you had a metadata undefined, and then you also had a spec field.
Yep.
But that spec field is not typed, right?
Yeah, exactly. So I think what we found out, yes, it has a lot of different parameters, which might make sense for platform engineers, but sometimes not make sense for, like I would say, the scientists, who want to run PySpark transformations. We try to give them a simple way to submit those jobs, but at the same time, they have a way to configure this via like options. So there are some things how they can, have more flexibility. If they want to, have like metadata, custom metadata, or other parameters, we try to understand like what parameters are essential, but work kind of like kind of optional. For example, like volume specs, right? I don't know, like or any other Kubernetes specifics, right? Which might not be really relevant to typical Spark user who just want to run simple transformations, right? Um,
Yeah, that
yeah,
makes sense. I was just kind of concerned about having if you have a typed spec, then
yep,
if you were to change our spec from spec operator side of things, then you might come to a problem. But doesn't seem like it's the issue here, so I just wanted to double check.
yeah. So like we don't expose all of this parameters from spec. But this is like what we're planning to do while working with the customers, with users, like who want to who give us some sort of feedback, what is needed, what is not needed, and then we can, expand this API, this connect API to make it more, to make it to actually, to work better for different use cases, right? For example, like one of the debates we have, do we want to export a driver configuration on the connect API? Like, do we have a bunch of use cases when users want to configure the driver, I don't know, resources? So this is something we want to learn from, from users who try to start adopting these Python APIs.
I see. I see.
Yeah. Any other questions?
So yeah, Andrew, just a comment on this, right? So we are also evaluating Spark Connect in our platform. So currently we do have a batch gateway service which is inbuilt, which is kind of similar to what Apple also has. It
Yep.
is as of now serving all the batch jobs wherein we have task APIs wherein users submit a tasks to this gateway, and then ultimately it every task translates into a batch Spark job in Kubernetes.
Yep.
Right, just to optimize a pod churn and IPs resource utilization, we are evaluating whether we can still continue to operate in batch mode, but behind the scenes we can create Spark Connect, a pool of Spark Connect servers dedicated to different teams.
Yep.
So that is where we are evaluating whether we should directly give the Spark Connect client to the users, which is what you are showing, wherein they will manage the client, they will manage retries and whatnot, or
Yep.
we can abstract this in a platform wherein they will continue to submit batch jobs, and then
Yep.
the gateway service behind the scenes spins up Spark Connect servers, maintains sessions, and so that is
Yep.
what we are
Yep.
evaluating. I will let you know how it goes, and I will also stay in touch with the community.
Yeah, I would love to like learn more from you. I'm very aware of batch processing gateway. The folks who actually I think they've been using this Go like Spark operator before to support multi-cluster job submission as well. So a couple of things I want to say. So from our perspective, Spark Connect is it's mostly for interactive Spark submission. Like imagine I have a notebook when you want to connect to your Spark cluster and run some quick experimentation, some sort of interactive experience. But more for like a batch experience, you might want to create, you want to use Spark application CRD, which basically behind the scenes, I guess, create a Spark cluster and run one Spark tasks, one task on top of this cluster. Um,
Oh yes, and
one, yeah,
that is
but
that is exactly the debate that we are also having
yeah,
in the engineering group. Is yes, Spark Connect looks promising, but as you said, using that for batch workloads, we might
yeah.
run into a lot of blind spots. Yeah, you're right. Yeah.
Also, like I think I want to say one of the very interesting discussions I had before. So we do have integration with Q. Like, have you heard about KQ project?
We have heard about it, but we haven't explored or did any POCs around that.
Yeah, so definitely try to take a look because I know some of the contributors start to integrate Spark application to Q job framework, and I think we already do have this support. I think so it's basically I don't know if they have documentation about it, but like the Spark application already supported in Q, and
Mm-hmm.
Q support the feature called multi-queue, which means like you can basically orchestrate the workloads across multiple clusters.
Got it.
which
Got it. Yeah.
and which means you can theoretically, so once Spark application CRD is supported in multi-queue, we
Mhm.
can eventually use this SDK to dispatch Spark jobs across multiple clusters.
Makes
Because
sense.
from the user experience perspective, they still interact with a single cluster, but you do have this kind
Mm-hmm.
of queuing system which kind of dispatch a workload on a different clusters where I have a capacity available. Which is also pretty powerful, when if you have like multiple Kubernetes clusters, when you run your Spark jobs, and you want to have a way for users to, admit their workloads across all those regions, right?
Makes
Um,
sense. Makes sense, Andy. Yeah. This is nice, right? Because we do operate in almost hundreds of EKS clusters, and our gateway does the load balancing and the fairness
yeah.
distribution of jobs. Yeah. Thanks.
Yeah, I think this is definitely something we should explore in the future. I mean, I would love for us to continue these Q efforts because I think integration Spark application with Q would be really interesting for many different scenarios. Um,
Yeah,
maybe
I
we can
agree.
follow up. Mhm.
I think we have integration with Unico and Volcano right now, but
Mm.
Q is definitely emerging as one of the technologies that people are interested in. So I would definitely love to see integrations or examples right around using that with Spark and everything.
Yep, that makes sense. I think maybe one for people will jump to the MCP. So I think we need to. So one of the things we probably need to create is the Spark Python. Basically, we need a Python package for Spark modules. I don't think we have it right now. So I think this is something I need to speak with Shekhar, like similar to how because today, as I showed you in this SDK, we do just use the JSON format to create this, the CRDs. This is not ideal. Ideally, we want to use the custom Python modules. So we need to basically build a Python package for Spark APIs, Python APIs, which actually allows us to do something like what we do for the train jobs. Um, I think it's here. So basically, we can import. Um, 1 second, let me quickly show you. Um, yeah, we can import models from this is our Kubeflow KT package for our optimization jobs. But we need to do something like similar to from Kubeflow Spark API import models, and then we can like reuse these models across the SDK. So we can import them directly as the class as instances, and then we can leverage them to have more kind of um, API driven way to submit the jobs instead of using the JSONs. I think this is something we need to work on with you guys. I will create an issue to track it, and maybe assign someone to work on it. All right.
Let's see. Let me share my screen. Mhm.
I was going to see the one question from Vincent around OCM add-on to do what Q could do around the Spark operator, right? Um,
That wasn't a question, that was a statement.
oh, okay. Okay. Do you have like your own scheduler plugin? Um,
The proof of concept that I made around using OCM was just it would pretend to kind of be like we would use the Spark application CRD and then it would handle doing part of the problem that we had, or is well, that we were kind of inventing for ourselves is just the cluster management and the whole life cycle of everything.
yep.
Uh, and so just basically be creating like clusters and node pools and all sorts of allocations on demand, but also like handling version updates and stuff like that. Um, and for our internal architecture, it kind of makes more sense to have OCM handle that. Uh,
Okay.
but it's very much a proof of concept right this second.
Yeah, yeah. I mean, like, I think there are a lot of really innovations we can do with Q, and I mean, I would, I mean, I know we already had done some. So I think Shingo already he's doing some work there, but I think it's still work in progress to fully support it with the Spark, I mean, with Q job framework. But I think we would love to like learn from you guys, like why do you use OCM? Like what is your kind of limitations today to use different resource quota managers? Maybe it's something like topic we can talk. We can talk next week as well if we have time, Vincent. If you can briefly
It's
talk
not
about
a resource quota thing.
the cluster management.
It's a versioning of all of the artifacts. It's the entire it's not just like we're deploying a Kubernetes cluster. It's we deploy a Kubernetes cluster and then like dozens of other things uh,
Okay.
because of security or whatever. Like that all has to get tracked and versioned and updated and so on and so forth.
Is it
But
like a cloud formation thing? Like, um,
yeah,
how do you? Mhm.
you can think about that, but it's just like um, uh, the whole the whole concept of platform engineering where where you have like teams that are just that are providing you like a Kubernetes as a service kind of thing,
I see.
but on top of all the things that we need for as an enterprise um, to handle security integrations and logging and monitoring and all of our own internal bespoke stuff.
Yep. Yeah, makes sense. Yeah, I think I haven't really explored the open cluster management, right? Um, because I know that you're talking about, Vincent, this project, right, where I have add-ons with OCMs, right? Um,
Yeah, open cluster management.
okay, okay. Yeah, I don't know if they have Q add-on. Like we need to see. I because again, I think folks managing the resources differently. I mean, I think there's project called Key. I think Crow as well. I think Kubernetes Resource Orchestrator. I think there's also Cloud Formation, from AWS, right?
Yeah.
Um, yeah, but
Wow.
yeah,
Yeah, and OCM looks like it matured quite well. I looked at this a couple years ago, and it was definitely still in a rough place, but seems like it has matured quite a bit. So yeah, I'll be very interested in like hearing more about the OCM and everything. All right. Let's see. Let's just get started with the demo. Yeah, so let's see. We have developed this Spark History MCP server. This is essentially a way for your AI agents to interact with the Spark History server, right? So, for those of you who may not know what Spark History Server is, Spark History Server is essentially stores all the information about the Spark job you have run in the past. And it allows you to kind of look at what had happened throughout the life of that particular job. Like how many executors were added, how many GC cycles were there, and like how much time you spent in GC, and all that information is exposed as a consumable information. It's being used for human consumption, but there is an API that we can leverage to get the information for the AI agents get information from. So this is why we created this Spark History MCP server. This allows you to, like I said, it's fairly easy to set up. If you look at the, quick start, all you really have to do is run some commands, and it'll get you started with the, quick start kind of things. We include some of the, example data, so that you can, start using the data without using your actual, Spark History or Spark job data. And in our case, we have these, example Spark jobs, and you get the exact same data that you'd get if you follow the quick start README. And we have like TPCD benchmark, New York taxi data, and all that stuff, right? And if you click on these, you get all the information like I talked about, job data, stages, executors, all that data. So let's see here. And if you connect the MCP inspector tool, right? So if you don't know what MCP inspector is, it just allows you to connect to MCP servers without, filling with like, curl commands or like dealing with the different, parameters for curl and all that stuff. So all you have to do is launch this and then connect to the MCP server running locally, and then you get to see those different resources, tools, and all that stuff. As well as the the resources available for MCP servers, it's more essentially just all tools. And if you just click on tools, we see that all these essentially functions that's available for the AI agents. So the easy one would be list applications. This is just going to list all the applications that's available for this particular MCP server. So if I want to run this tool, we will get some information back. So in this case, just showing you all the information about the jobs that's available. So these just corresponds to the information that was shown at the very end or very beginning here. Okay, so that's what the MCP server is, and I'm just gonna switch over to my terminal really quick. Let's see here. All right. So for this particular demo, I'm just using the Kiro CLI. So this is just Amazon's agent CLI that's available. So in here, this command I've already run, but just in the just to kind of show you how you set up for your use. So all you really have to do is just run this one command, and you're saying, hey, QCLI at this MCP server with this name, and then the command that you want to run is a UVX, blah, 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 right? And then once you run that, the MCP server is going to be available for the agents to use. So in this case, I say QCLI. And right here it says Spark History loaded in 0.7 seconds, and then the MCP server should be available. So if I were to ask, see what tools do you have, and that should come up with some information about the tools provided by MCP. So it says Spark History server analysis, file systems, all that stuff. So we can just ask it to some information like see so how many applications or Spark applications we have, and it's just going through the entire workflow, right? Like as in just get the applications and then parse all the information and then come back with some human consumable information here. So I can then just ask it like, hey, can you tell me about let's see, TPCD, TPCD, good job. And then it's going to call a bunch of, MCP server tools. So like, in this example, you can see which tools are being used, right? So here it says get application. So I just approve that. And then also list of jobs, approve that. And then get executor summaries or approve all that. And then once you get all the information, it's going to go through and think through and all that stuff, right? And then let's get more information here for you. Right now, I'm doing all the manual approval and all that stuff, but you can make it so that it doesn't need the manual approval every time. And looks like the context window was a Kubeflow, so just trying to summarize. And let's see, and it just gives you some information, how many times you saw, how many, how long it took, how much resources it took, how much data was consumed. And then some storage jobs, storage stages, all that information. And then from there on, you can ask more about, what happened to, jobs and all that stuff, right? So let's see. For our example, there is a, let's see. So we have two jobs that are somewhat similar here. So we have the New York taxi data here, and then there's another New York taxi data here. So we can actually ask it to compare these two jobs as well. So, in real world, you might have like, two identical jobs, but one might have finished earlier, the other might have, finished later. And if you want to like, compare that, the performance issues between these two, then you can do that, right? So you just approve that. So there's, these compare job performance call. These are actually not direct API calls. We actually built some, tooling around, certain parameters that are usually relevant to jobs. So here you can see that, some apps were taking some time, and you can tell like GC times and all that stuff, right? So so you can tell that the how much time it used and why, right? In this case, it took 2 times the amount because it used the 2 times the volume, and and this kind of things can be used to infer these job performance differences, I guess. Any questions on this?
I have a question regarding using the tool itself. Can I just download the Spark logs and then plug it to MCP?
Download, sorry.
Download the logs instead of
Yeah.
running.
Yes. So
Is
if you
that
have
what
like,
you're doing right now?
so
Like,
this, yeah, so let's see here. Put that here. So this is the repository that we have for the MCP Spark, right? And the data that I have is actually under the examples folder. So examples, it's somewhere. Yeah, but yeah, hold on, examples. And let's see, so like a basic, and then so events. All right. So, for this example, we actually have these 4 jobs, right? So these jobs are the ones that corresponds to the jobs available to the Spark history server. So all we are doing in this repository is that we are just mounting this folder and then presenting as jobs. But if you want to use it for your use case, you can just download the Spark events and to your local machine and then point your MCP server to that.
okay, thank you.
Tariq, do you have a question?
Yeah, I was wondering, so this MCP server implementation for the Spark History server, is this independent of whatever cluster you're using, standalone Kubernetes, Mesos, Yarn, or does it have any integration with whatever exists with Spark operator implementation with
So
Kubeflow?
we
Or
don't. Yeah, so this is essentially just very standalone thing. So it can be used Yarn based, doesn't have to be Kubernetes. If you have a Spark job that's run and Spark history server can process it, then there's really no restriction as to what type of jobs you have, right? But we do also provide Helm charts so that you can deploy this to your Kubernetes. And as far as target audience is concerned, and it's definitely on the Kubernetes deployment in mind, I guess.
Makes sense. Yeah.
Yeah, I have like a few questions in terms of the deployment of the server. So from my understanding, you do have the Docker container, right, to deploy the server anywhere, correct?
Yes.
Um,
Mm.
how do you managing the deployment of the servers and how do you expose the tools to agents? Um,
Sorry, say that
like
again.
so you like I think all the demos you show like an agent running locally, right? With Claude or any other agents, right, which can interact with those tools. So where do you run the server by itself?
So
Does it
server,
also running locally?
yes, the server runs locally as well. So
Mhm.
here we have just have the Spark History server. Right, and then we also have the task actually running. Let's see. So you can see that task.mcp. So task is running locally on this machine. Then also the Spark History server is running as Docker image. But we also provide Docker image of MCP server itself, meaning that you can actually use that to deploy it to your cluster as well.
Mm-hmm. Does it have any kind of like guardrails or authentication, like to understand which Spark history servers it can access? Like, what is the auth story there?
Yeah, so we have the configuration file here. We have a whole bunch of options that you can use. So it's
Mm-hmm.
not going to connect to all the Spark History server that's available. So you essentially just have to define which servers you want to connect to. So here we are saying that the only server you can connect to is local, and then here's the URL, right? And then we can also have some authentication information if you want to use it. And there are other configuration options that are here. All these should be documented on the README as well. So if you have any questions, you're definitely happy to help.
Yeah, makes sense. And like, I guess like, do you manage, like, how do you manage multi-tenancy in that case? I guess like, different organizations managing Spark history servers differently, right? I don't think it's any auth, right, in front of history server, which kind of
Yes,
have multi-user
yeah,
support. Yeah.
exactly. The authentication in the Spark History server itself is a little tricky. What I've seen is that people just use some sort of a proxy in front so that you don't have to deal with it within the history server. So you might have like I don't know, Caddy or NGX or something that can handle the authentication on its own, and then go to the whichever history server you want to use. And as far as MCP server side is concerned, we don't really have the authentication um, authentication for the purpose of using it as a multi-tenancy in mind. I think the deployment model tends towards having multiple of these. So you might have like different Spark history server for different teams, and then they can use that and then point that to like any server you might have.
Yeah, it makes sense. Yeah, so I know like protocol itself has a sort of authentication best practices, but like I don't know, I guess like you don't really use any of those protocol specifications, right, for your server.
Right.
Um, hmm
We do support some basic authentication like the
Yeah.
username passwords, but for
But
most cases
does it,
probably not.
so do you expect users to pass this as part of the context for the tools? Like,
So that becomes quite tricky because it's
mhm.
generally not a good idea to pass
Yeah,
in
exactly.
authentication information to LLM directly. It's usually that you have some sort of actual process that it's, handling this person authentication directly. So yeah, yeah, if you were to architecting something like that, yeah, I would definitely not pass
I
in
think identity, yeah,
credentials
yeah,
like that.
I agree with you. I think identity is a very tricky question. Like it's very hard to like how you're going to identify which agents or which clients access the server, right? And then make a decision. I know there are some solutions, different folks. I think there are no standardization, right? In a way, how you authorize clients, right, to the servers.
Yeah.
Mm-hmm. Makes sense.
Any other questions I can answer before moving on? right. Let me just stop sharing and see the agenda doc. Yeah, so the last one is mine as well. So let me share. All right. I just wanted to bring in some quick information about the benchmark results we have been running for a while. So we have we have run the Spark operator benchmarks. You can see that the benchmark results here. This is also available on the Kubeflow, website as well. But we have also run some, benchmark results on using the Apache Carbon, using the TBCDS benchmarks as well. All these findings are here. Some of these, findings are quite interesting, especially if you're, operating Apache Spark on a large scale. Caliban is definitely something that's coming up quite more often. So hopefully this can help you, decide what kind of configuration you want to use. And we also have the Spark Gluten Velox benchmarks. All these are also available here. This one's particularly interesting because it actually gives you a lot of performance increase without changing too much of your configuration. And some of the performance gain is truly remarkable. And then finally, we have the Spark Rapids. This is just essentially just using a GPU instead of CPU to run your Spark benchmarks or Spark workloads. This is coming up more often for nowadays. So what usually some of the operations that Spark is performing can easily be translated into GPU operations. So like if you combine that with Gluten Velox plus the GPU, it's a quite nice story here, right? You can expect some significant performance gains. So I just wanted to let people know that these are here, and if you want to take a look and have discussions, let us know, and we will be happy to help you out.
Do you have any tests ran on this accelerator called Comet?
Comet, yes, Apache Comet and Comet and Fusion, is that right? Forgot the name. But yes,
Yeah, it's
Velox
Data
and
Fusion
Yep,
Comet.
that's
Yeah.
right.
yep. So Velox, Data Fusion, they are somewhat similar in that I think they operate on the same layer when you're executing the query, right? And I think there was some information around the differences between the two. But I would rather direct you to that documentation than me making the comments here. But the technologies used and the underlying logic and all that should be somewhat similar.
Yeah, I think we've done. I don't know if they publish results for Comet. I saw some of the benchmarks they've done before. I can double check for this see if they're available. But I think I suggest you to check this this repository, I think, as well. They do maybe have something there. So
Yep.
Manabu, you haven't really tried to run Comet yet, right?
No, not yet. But this would be definitely an interesting things to try next.
Makes sense.
I also put the link to the comparison documentation there. But yeah, you can now take a look and see what fits you the best. All right. Any other questions or anything we can answer?
So those benchmarks, they're available on data on EKS right now, right?
Yep, that is correct. Let me just put the link in the doc as well so that you can have it.
Yeah, I'm curious if we should put it to the docs as well. I think we only have like one benchmarks we've done like a year ago, right?
Yeah.
I have another question regarding Spark history servers. We are kind of using the chart developed by CubeDay earlier. I think now it is donated to Apache. The chart. So we are seeing some inconsistencies, like when we click on this application logs and then try to load them. First time it doesn't load well, and then it takes some time, and then it takes a lot of time. Like if the job event logs are like ran for like 15 minutes or more, it takes a lot of time, like to load it again, like first time, I think. Any recommendation about what resource usage or like what the application is doing here?
Yeah. Sorry. Which Spark History server Helm chart are you using?
It was called CubeDay before. I think
Oh, right.
Vara was the one
Yes.
maintaining it.
Yeah, actually, I maintain that too. Yeah. So as far as the your issue of applications taking forever to load on Spark History server, it happens often when you are processing a large you know Spark jobs. And for example, I have a job that ran for like 8 hours or so, and it took my Spark History server like 10-15 minutes to parse. And it happens, and it's very difficult to optimize that, right? Because we don't really have resources to optimize that within the Spark History server code. But as far as making it faster for substantial or sub that the second time that it runs is that you can use the persistent feature, meaning that you can actually save all these processed Spark History server information or Spark job information into a local RocksDB files essentially. And this is actually supported within the Helm chart as well. I think we added that feature a few months ago or so. So try that out and see if that works for you. But it will take for a while for the jobs to be parsed first time. The database is going to help you the second time you're going to use that job, but that first time there's really nothing that we can do.
Okay, thank you.
Yeah, I think Vara also talked about it. These Helm charts might be transferred to Kubeflow organization so we can maintain it together.
Oh, that'd be great. Yeah.
Yeah, we should talk about this at some point. Because I guess like there are not really a single place, right, for folks to deploy history server right now, right?
Yeah.
I think we will try to maybe move them on the Spark operator, but yeah, I think there are some concerns we had before.
Yeah.
So anyway, we can talk about it later.
Yep. Awesome. Looks like we have time. If anyone have like last minute questions, now it's the time.
Right. So I guess like thanks for the demo. Really exciting to see this Manabu. Like I'm looking for, like for MCP server, definitely like we should think more on the integration. I think, like maybe I know there are some organizations already starting adopting this. So we'd love to hear from them what are like, the challenges to run this in production and how do they run those servers with their agents, especially like, a non-local based deployment, because I think there isn't really a good way right now to managing those servers due to protocol limitations. So looking forward to this. So thanks everyone for your time. I guess like speak in 2 weeks. Feel free to propose topics for next agenda items. Exciting to talk with you or other demos for Spark and other data on Kubernetes topics. Thanks everyone.
Thanks, guys.